Yes, my dears. Now, there are some questions that I don't want to get lost within the documents I've explained. That's why I want to explain it to you again as a single question. I especially think about this for the questions that are really good. Now, this one asks us to factorize it. The complete cube of a plus b plus c minus a cubed minus b cubed minus c cubed. If you haven't tried it yet, you can pause and give it a try. Let's take two of these three terms inside the parentheses. So, for example, let's consider a plus b as m here and think as if we're expanding the cube of m plus c. What will we get from here? We begin with the cube of the first term, which is then added to 3 times the square of the first term multiplied by the second term. Following this, we further add 3 times the first term, which is then multiplied by the square of the second term, completing the full algebraic expansion, plus the cube of the second, minus a cubed, minus b cubed, and minus c cubed. First of all, this and this cancel each other out. When we expand this, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. This with this and this with this will be eliminated. So these two will remain. This will remain and this will remain. When we factor 3ab from these, we are left with a plus b. And as for the ones here, when we factor out 3a plus b times c, we are left with 1a plus b here. Here we took the 3, the a plus b, and the c. There will be one c left. And since it's a plus here, it's plus c. Now we will take the 3. We will take the a plus b. So we have 3 times a plus b times ab. Plus, what do we have from here? We have ac plus bc plus c squared. These have come together. So what do we do after this? With this and this, when we take b as a common factor, we are left with a plus c. When we take c as a common factor from this and that, again we are left with a plus c. Then, when we take a plus c as a common factor here, we are left with b plus c. At the front, we also had a plus b and 3. So this is our answer. In my opinion, it was a really nice question. Agreed? All right, see you in the next one.